Good morning, students. Chapter 6, Work, Energy and Power. Yes, we have discussed about what is work, what is energy and what is power. Now, in this section, we will see one important phenomenon, that is collision. What is collision? Yes, you know numbers of example for collision. Okay, in billiards game, then in carom. Okay, then in marbles when you are playing with marbles. In this each and every case, okay, yes, it is collision between two objects. It is collision between two objects. Okay, so yes, in physics, during collision, what changes? Okay, how direction of object changes after collision? What is energy after collision of object? Okay, that we will study under this case, under this section. Okay, yes, collision. There are numbers of there are types of collision. Okay, elastic collision, inelastic collision, completely inelastic collision, or you can say perfectly inelastic collision. Okay, today in this lecture we will see elastic collision. So collision, yes, you know what is collision. Okay, if I have one object like this, okay, and if I throw another object in this direction, then yes, they will collide with each other. They will collide with each other, and after collision, yes, they may change their direction. They will move in one direction, they will move in another direction. Then yes, it depends on collision. It depends on collision. Okay, there are some collision in which yes, two objects they may not be in contact. Okay, if one object is moving closer, and after some distance, it will change its direction. It will change its direction. Okay, so yes, there are numbers types of collision. Okay, today we will see what is elastic collision. What is elastic collision? Yes, in every type of collision, law of conservation of energy and law of conservation of momentum is applied. In every collision, okay, every collision, okay, law of conservation of energy and law of conservation of momentum, they are obeyed. They are obeyed. Okay, see, in every collision, law of conservation of total energy, law of conservation of total energy and momentum are obeyed. So what is difference between such elastic collision and inelastic collision? Yes, okay, if kinetic energy before collision, if kinetic energy before collision is same as kinetic energy after collision. If kinetic energy before collision is same as kinetic energy after collision, such collision is termed as elastic collision. Clear about this? So yes, in this elastic collision, we can say kinetic energy is conserved. Kinetic energy is conserved. Clear about this? So yes, before and after collision, kinetic energy remains same. Before and after collision, kinetic energy remains same. Clear about this? So yes, elastic collision, if kinetic energy before collision is same as kinetic energy after collision, such collision is termed as elastic collision. Okay, now first of all we will study elastic collision in one dimension. First of all we will study elastic collision in one dimension. See how elastic collision elastic collision in one dimension. Elastic collision in one dimension. Okay, see, elastic collision in one dimension. For that, we are assuming, let we have two objects. Let we have two objects having masses m1 and m2. They are moving with speed u1 and u2 in x direction. In x direction. This situation is before collision. This situation is before collision. Clear about this? Okay? Yes, we have two objects. We have two spheres, for example, m1 and m2, having masses m1 and m2. They are moving with speeds u1 and u2. So this situation is before collision. Let after collision, if u1 is greater than u2, then obviously m1 and m2 they will collide with each other. And let after collision, their speeds are, after collision, their speeds are, that it is m1, it is m2. It is moving with speed v1 and it is moving with speed v2. This situation is after collision. This situation is after collision. Clear about this? So yes, here I am assuming, okay, let two objects having masses m1 and m2 are moving along x-axis, means one dimension. Okay, let their speeds before collision, let their speeds before collisions u1 and u2, and let their speeds after collision is v1 and v2. So yes, be clear about these notations for speed. Okay, u1 and u2 speed before collision. Okay, v1 and v2 speed after collision. Clear about this? Yes. In collision, when two objects collide, their masses remains same. Okay, if they are not disintegrated. Okay, so yes, it is situation before collision, it is situation after collision. Okay, now as it is elastic collision, in every collision, law of conservation of total energy and momentums are obeyed. So yes, here what we have to find, see, you will be given masses of two objects and their initial speed. What you have to find? Speeds after collision. Okay, yes, you will be given m1, m2, u1 and u2. You will have to find v1 and v2. Okay, what is speed after collision? Okay, so how to find speed after collision? See, first of all, we will take, okay, according to law of conservation of momentum. According to law of conservation of momentum. What is law of conservation of momentum? Total initial momentum is equal to total final momentum. Means initial momentum means total momentum before collision is equal to total momentum after collision. So see, before collision, this m1 object is moving with speed u1, so its momentum is m1 u1. Clear about this? This object is also moving in same direction, so its momentum is m2 u2. Clear about this? Is equal to, after collision, this object is moving with speed v1, so it is m1 v1, and this object is moving with speed v2, so it is plus m2 v2. Clear about this? According to law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, because they are moving in one direction. Clear about this? Okay. Now, see, it is m1 u1, it is m1 v1. Okay, take terms having one, means for object 1, take terms in one side. So I can write it like this: m1 u1 minus m1 v1 is equal to m2 v2 minus m2 clear about this. Okay, now take m1 common, so m1 common, here it is u1 minus v1 is equal to m2, here it is v2 minus v2. Equation number 1. Equation number 1. Clear about this? Okay, simple. According to law of conservation of momentum, total momentum before collision is equal to total momentum after collision. Okay, yes, it is first. Now I will take another relation, that is from law of conservation of kinetic energy. Law of conservation of kinetic energy, because in elastic collision kinetic energy is conserved. So according to law of conservation of kinetic energy, according to law of conservation of kinetic energy. Okay, see here it is. Kinetic energy means half mv square, half into mass into square of speed. So see, this m1 block is moving with speed u1, so it is half m1 u1 square plus for this block half m2 u2 square. So it is total kinetic energy before collision is equal to total kinetic energy after collision, half m1 v1 square plus half m2 v2 square. Clear about this? Clear about this? Okay, so see this half cut. Okay, so yes, this half and half cancel out. Okay, now again take terms having one side, so we will get m1 u1 square minus m1 v1 square is equal to right hand side, it is m2 v2 square minus here it is m2 u2 square. Okay, clear about this? Okay, now see here, take m1 common, so m1 common, here you will get it is u1 square minus v1 square is equal to this side m2 v2 square minus u2 square. Clear about this? Clear about this? Now yes, you can say it is equation number 2. Yes, it is equation number 2. So yes, by applying law of conservation of momentum, you have to obtain equation number 1, and after applying law of conservation of kinetic energy, you have to obtain equation number 2. Now we will take ratio of these two equations, that is equation number 1 and equation number 2. We will take ratio of these two equations. See how to take ratio. Equation number 2 divided by equation number 1. Equation number 2 divided by equation number 1. See this. Here it is m1. Here it is m1 u1 square minus v1 square. Okay, u1 square minus v1 square is equal to m2 v2 square minus u2 square divided by equation number 1. Yes, here it is m1 u1 minus v1 is equal to this side m2, it is v2 minus. Clear about this? Again see, it is equation number 2, it is equation number 1. You have to take that ratio. So see, m1 cut, m1 cut, m2 cut, m2 cut. Now see in numerator, it is u1 square minus v1 square. Yes, you know what is a square minus b square. It is a plus b into a minus b. So how to write this? Yes, I can write this as u1 minus v1, u1 plus v1 divided by it is u1 minus v1 is equal to this side v2 square minus u2 square means it is v2 minus u2 v2 plus u2 divided by v2 minus u2. Clear about this? Okay, u1 square minus v1 square is equal to u1 minus v1, u1 plus v1. Similarly, v2 square minus u2 square is equal to v2 minus u2, v2 plus u2. So see, u1 minus v1, u1 minus v1, u2 minus v2, v2 minus u2. So you will have u1 plus v1 is equal to v2 plus, clear about this, u1 plus v1 is equal to v2 plus u2. let it is equation number, clear about this? Clear about this? So yes, we have three equations. It is according to law of conservation of momentum, it is according to law of conservation of energy, and by taking ratio of these two equations we will get u1 plus v1 is equal to v2 plus u2 is equal to v2 plus u2, and it is called Newton's law of impact. This u1 plus v1 is equal to v2 plus u2. It is called Newton's law of impact. It is called Newton's law of impact. It is called Newton's law of impact. Also here it is. See, if I can write this equation as yes, here it is u1 plus v1 is equal to it is v2 plus u2. It is equal to it is v2 plus u2. I can write this equation as u1 minus u2 is equal to v2 minus v1. This u1 minus u2, it is called relative velocity of approach. Relative velocity of approach. And this v2 minus v1 is called relative velocity of separation. Relative velocity of separation. Clear about this? u1 minus u2 is called relative velocity of approach because its speed is u1. Initially they are moving towards each other. Okay, if they will move towards each other, then collision is possible. So yes, u1 minus u2, relative velocity between these two objects before collision is called relative velocity of approach. After collision, they will move away from each other. So it is called relative velocity of separation. And yes, ratio of relative velocity of separation to relative velocity of approach is called restitution constant for collision. Okay, and it is denoted by small e. What is restitution constant? E is equal to v2 minus v1 upon here is u1 minus clear about this? So yes, this extra point you have to remember. Okay, what is restitution constant? Now again back to our original question. Okay, we have to find what is value of v1 and v2. Yes. First equation from law of conservation of momentum. Second equation from law of conservation of energy. Take their ratio, you will get this third equation, that is u1 plus v1 is equal to v2 plus u2. Now how to find? See, we will multiply this equation number 3 by m1. And then we will add this equation in equation number 1. What is method? Again, we have to multiply this equation number 3 by m1. And then add in this first equation. Okay, then how to calculate? See. Again, see, it is equation number 1, it is equation number 3. Now we will multiply this equation number 3 by m1. Okay. Multiply equation number 3 by m1. Then see, it is m1 u1 plus m1 v1 is equal to m1 u2 plus m1 v2. Okay. Now you have to add this equation in equation number 1. You have to add now add in equation number 1. What is equation number 1? Here it is. It is m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. So now you have to take addition of these two equations. You have to take addition of these two equations. If you add these two equations, how to write? See, first of all, we will take addition of left hand side. M1 U1 plus M1 V1. This one. Now plus M1 U1 minus M1 V1. Clear about this? Is equal to, now right hand side, M1 U2 plus M1 V2. Okay, now this term plus M2 V2 minus M2 U2. Clear about this? This equation which is multiplied by M1 3 and it is equation number 1. Okay, you have to add that. So yes, here it is M1 V1 cut, M1 V1 cut, and yes, no other terms. So yes, we can simplify now this. Now we can simplify this. Yes, we have to find V2. We have to find V2. Here it is now having V1, here it is now having V1. So I can write it is 2 M1 U1 is equal to this side. Here it is M1 M1 M2 M2. So first of all, as I have to find V2, I will take these two terms together. I will take these two terms together. Okay, so I can write M1 U2 minus M2 U2. Yes or no? M1 U2 minus M2 U2 plus M1 V2 plus M2 V2 plus M2 V2. This and these two terms together. This and these two terms together. Okay, so yes, 2 M1 U1 is equal. From this I can take U2 as common. From this term I can take U2 as common. Okay, then yes, here I will get M1 minus M2 U2. Clear about this? M1 minus M2 U2 plus from this side, if I want to find V2, then I can write it as M1 plus M2 V2. M1 plus M2 V2. Clear about this? Clear about this? Now as I want to find only V1 and V2, here this term having U1, here this term having U1, here this term having V2, and as I want to find only V2, and as I want to find only V2, how to write this? How to write this? See, I can divide this equation by M1 plus M2. Let's see, if I divide this equation by M1 plus M2, 2 M1 U1 divided by M1 plus M2 is equal to M1 minus M2 divided by M1 plus M2 U2 plus M1 plus M2 divided by M1 plus M2 V2. Clear about this? Divide this whole equation by M1 plus M2. So this M1 plus M2, this M1 plus M2 cancel out. Okay. Now if you make V2 as subject, then this term we have to take this side. So yes, V2 is equal to what we will get? V2 is equal to, it is 2 M1 upon M1 plus M2 plus M2 U2 minus, this term we have to take this side, minus it is M1 minus M2 upon M1 plus M2 U1. Clear about this? Clear about this? Yes, here it is 2 M1 U1, okay, M1 plus M2, and this one it is M1 minus M2, here it is U. Okay, so yes, it is equation of V2. Yes, it is equation of V2. Clear about this? Clear about this? Okay, so yes, here we have to remember this equation, that is V2 is equal to 2 M1 upon M1 plus M2 U1 minus M1 minus M2 upon M1 plus M2 U. It is only equation of V2. It is only equation of V2. Now we will have to find what is equation of V1. What is equation of V1? How to find equation of V1? See, from this equation. From this equation, you have to make V1 as subject. You have to make V1 as subject. So see, from equation number 3, if you make V1 as subject, then V1 is equal to, here it is, U2 plus V2 minus V1. U2 plus V2 minus V1. Clear about this? Okay, that is equal to V1 is equal to U2 as it is plus what is equation of V2? This whole equation, that is 2m1u1 upon m1 plus m2 minus m1 minus m2 u2 divided by, here it is m1 plus m2 minus, here it is u1 minus, here it is u1. Clear about this? Now take m1 plus m2 as LCM. Take m1 plus m2 as LCM. Okay, so V1 is equal to, here take m1 plus m2 as LCM. So here it is LCM. Here it is only u1. So here you have to multiply m1 plus m2. So u2 m1 plus m2. u2 m1 plus m2. This term as it is plus 2m1 u1. This term minus m1 minus m2 u2, and with u1 you have to multiply m1 plus m2. Clear about this? Okay, so yes, v1 is equal to, now we have to simplify this. See, m1 u2 plus m2 u2. Clear about this? Plus 2 m1 u1. Now take care here in this term, minus m1 u2 minus m1 u2, minus minus will become plus m2 u2 minus m1 u1 minus m1 u1 and minus m2 u2. Okay, divided by, here it is m1 plus m2, here it is m1 plus m2. So now v1 is equal to, here it is, which terms are negative? Minus m1 u2 minus m1 u2 minus m1 u2 and it is m1 u2. So this term cancels out. Okay, another term is minus m1 u1 minus m1 u1. So yes, here it is minus m1 u1 and here it is 2 m1 u1. So we can cancel out this. m2 minus m2 v1 minus m2 v1. Here it is only minus m2 v1. So yes, we can take that term as it is. Now, how to simplify these terms? How to simplify these terms? See here it is. It is m2 u2. Okay, here it is m2 u2. So we can say here it is m2 u2. Here it is m2 u2. So we can say it is 2 m2 u2. Clear about this? m2 v2. This m2 v2. Now remaining terms are 2m1 v1 minus m1 v1. Yes or no? 2m1 u1 minus m1 u1. So I can write this plus m1 u1. Okay? And this last term is minus m2 u1. Here it is minus m2 u1. Okay? Clear about this? Divided by it is m1 plus m2. Divided by it is m1 plus m2. Okay, now you can separate these two terms like this. It is 2 m2 divided by m1 plus m2 divided by m1 plus m2 u2. Clear about this term? Plus, here it is plus m1 minus m2. Yes or no? m1 minus m2. Here it is m1. Here it is m1 minus m2. m1 minus m2 divided by, it is m1 plus m2, u2 is common. Sorry, u1 is common. u1 is common. Clear about this? So yes, it is equation of v1. It is equation of v1. This one, 2m2 u2 upon m1 plus m2 plus m1 minus m2 upon m1 plus m2 u1. Clear about this? So yes, you have to remember these two equations. You have to remember these two equations. Clear about this? Equation of v1 and equation of v2. Equation of v1 and equation of v2. Clear about this? Okay. So yes, you have to remember these two equations. Okay.